Okay, this is section 7, topic 4. So we're talking about graphs of exponential functions, and this is part 2. So sometimes we can use the properties of exponents to easily sketch exponential functions. So how could we use the properties of exponents to sketch the graph of y equals 2 to the x plus 2? So I'm going to give you a hint, and then I'm going to let you talk to your table. Remember, when we're adding exponents, okay, the time that we added exponents was when we were multiplying. It's going to give you about 30 seconds. Turn and talk to your table mates or to your group mates. What do you think? How do you think we could rewrite y equals 2 to the x plus 2? Okay, so hopefully we came up with something along the lines of y equals 2 to the x times 2 to the second. What do you guys think about that? It's kind of like we're going backwards of the x raised here plus 2. Okay, because we would add these because we're multiplying. We keep the base and add the exponents. But we're taking that and we're going backwards into this. Now, what can we do with this? What is 2 to the second? 4. So then if we have y equals 2 to the x times 4, does that look familiar? Does that look like something we've done before? It's very similar. Could we write it as y equals 4 times 2 to the x? Oh, that looks familiar. Doesn't that look like my standard y equals a times b to the x that I've been using to graph? So what's my y-intercept? Right, my y-intercept is 4. And what's my common ratio? 2. So my y-intercept of 4, I'm going to graph. And then my common ratio of 2, 4 times 2 is 8. 8 times 2 would be 16. When I'm coming this way on the graph, I know that I take this and instead of multiplying by 2, I'm dividing by 2. So when I come this way, I say 4 divided by 2 is 2, and 2 divided by 2 is 1, and 1 divided by 2 is 1/2, 1/4, 1/8, 1/16, and so on. So it's going to approach 0 down here and get closer and closer without ever actually reaching it. Okay, so this is my graph. So let's talk end behavior. As x increases, y increases, and as x decreases, y approaches 0. Let's look at the next one. So use properties of exponents to sketch the graph of y equals 3 to the negative x. So y equals 3 to the negative x. When I multiplied, if there's something being multiplied here, could I write this as y equals 3 to the negative 1 times x? Do you agree with that? Okay. So then when did I multiply exponents? When was the only time that I multiplied the exponents? Talk to your partner. Right, the only time I multiplied exponents was when it was a power to a power. So this is like y equals 3 to the negative 1 to the x, because that's like negative 1 times x. Well, what's 3 to the negative 1? We're putting all of these exponent rules together right now. 3 to the negative 1 means that 3 goes to the bottom, which means I have 1/3 to the x. This. And then one more thing. Remember, this is my common ratio. I know my b is 1/3. What is my a? Okay, you're right, the a is 1, so y equals 1 times 1/3 to the x. So a is 1. So my y-intercept is at 1, and then my common ratio is 1/3. So 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. 1/9 times 1/3 is 1/27. And then it gets progressively closer to 0. And then if I take this to the left, I would multiply by 3 because the opposite of multiplying by 1/3 is to divide by 3. Is to multiply by 3. The opposite of multiplying by 1/3 is to divide by 1/3, which is the same as multiplying by 3. So as I go this way, I'm at 1. So 1 times 3 is 3, and 3 times 3 is 9. And so this is what my graph looks like. Okay? And so we could, again, talk in behavior here as x increases, y approaches 0. As x decreases, y is increasing, and the graph as a whole is decreasing. So I want you to do this, try it. I'll give you a hint that it's like the very first example that we did, where we break it apart. But this is subtraction, so think about what that would have to be true of that 3. So I'm going to give you about 1 minute. See if we can come up with a difference and graph them. Okay, so if you need more time, then pause the video. But we could take this is subtraction. We could also write this as y equals 2 to the x plus a negative 3. That way we see that it's still addition. Okay, so then I have y equals 2 to the x times 2 to the negative 3. Well, 2 to the negative 3 is 1/8, so this is the same thing as 1/8 times 2 to the x. So my A is 1/8, and my B is 2. So this time, I start at 1/8, and then I multiply by 2 every time. So I start at 1/8, which you can't tell exactly where that would be. I would assume it would be somewhere in here. And then I multiply 1/8 times 2. So 1/8 times 2 over 1 is 2 over 8, or 1/4. That's getting a little bit bigger. About there. And then I have 1/4 times 2 over 1, which is 1/2. It's a little bigger. And then 1/2 times 2 is 1, and 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8, and then 8 times 2 would be 16, of course. Now you can kind of see the general trend even from here, that it's coming down, and it's going to approach 0, but never actually touch it, and then it's going to keep going up from here. Okay? So then let's look at the beat the test. So the beat the test says the graph that represents the function f of x equals -3 times 2 to the x has a y-intercept of blank, the graph is increasing or decreasing. So the A value, the y-intercept, is -3. The graph, let's talk about what this graph would look like, okay? Remember, you could memorize that chart to talk about the end behavior and where it's going to go based on each thing, but let's just sketch this, just kind of really roughly. I know my y-intercept would be at -3, okay? Let's think through this for a second. If I'm at -3 and I double it, where am I going to be? You're right, I'm going to be at -6. And then if I'm at -6 and I double that, where am I going to be? At -12. You're right, it's going to go down this way. But if I'm at -3 and I half it, then I'm going to be at -1.5. And if I'm at -1.5 and I half that, then I was at -3/2. Now I'm at -3/4. And so I'm going up and approaching 0 this way. So this would be my graph, okay? Really just by a little bit of reasoning. I don't even have to bust out the grid paper or anything like that. I can just kind of picture and reason what's going to happen with these numbers. So this graph is decreasing. And then okay, so far we have a y-intercept of -3, and we know that the graph is decreasing, and it's decreasing at, the graph is decreasing by a common ratio of 2, and it's decreasing as x increases and approaching 0 as x decreases. So be careful here. I think that the key that is posted on Schoology may have the incorrect answer if I have not gone back and fixed that yet. So be careful there. The PDF that Algebra Nation put out did not have the correct answer marked, but decreasing is the correct answer because as you can see from left to right, it is going down. Now, let's talk about the bottom. So which of the following have the same graphic representation as the function f of x equals 8 times 2 to the x? So it would have an a value of 8 and a b value of 2 to the x. So let's see if we can rewrite these a little bit differently. So I know that this would be the same thing as y equals 2 to the 3x. And there's really no way I can rewrite that to make this 8 and 2 to the x. So it's not this one. 2 to the 4x could be multiplication. So 2 to the 4th to the x. Well, 2 to the 4th is 2 times 2 times 2 times 2. So that's 4, 8, 16. So that would be 16 to the x, which is not the same as this. 2 to the x plus 3 is the same thing as 2 to the x times 2 to the third. Well, I know 2 to the third is 8, so that's 8 times 2 to the x, which is the same. That's what I'm trying to find. This one is 2 times 2 to the second to the x, which leaves me with 2 times 4 to the x, but I can't put these together and just get 8, so I'm just left with 2 times 4 to the x power. And then this last one leaves me with 4 times 2 to the x times 2 to the first, because I have the x plus 1, so I have the x and the 1 with the 2. I could multiply the 4 times 2 to get 8 times 2 to the x. So this is also a viable option that would give you the same graph once you broke it down in order to graph it. Okay, a few big reminders today. You will probably have time to do a little bit of classwork today, but after that, reminders, no tutoring today, homework on Schoology, and this is really important. You have a quick check tomorrow. Okay, it's probably been written on the board for you, but quick check tomorrow. So make sure if you need help to stop by Miss Rayburn's room or my room. Before school is a great time now that you have a little bit extra time in the mornings between 7:45 and 8:30, or stop by directly after school. Stop by whenever you can, whenever you need to. Maybe during your charger zone, you can come to my class. I don't have a class then. That might be helpful. Whenever you need help, stop by and let us know, please. Have a great day.